I've been working on QuantIC for a project called Indipix. It's a project about developing mid-wave infrared camera, what we call monolithic mid-wave infrared camera. That means that they are only made of one chip. The cameras that you buy that work in the mid-wave infrared range, they normally need two chips, one for the light sensors and one for the electronics. So what you need to do is combine these two chips together, and that process needs to be done on small chips, on small pieces of material, time-consuming, costly, and that means that the price for mid-wave infrared camera is really high. We developed a monolithic process where you have the light sensor and the electronics all on one material, and it's inherently low cost because you can do wafer scale processing. That means that you can process a lot of devices, a lot of camera chips at the same time on a wafer. Another reason why our technology is lower cost is because commercially available mid-wave infrared camera are cryogenically cooled. That means that they need to operate at very low temperatures, around -200 degrees Celsius. With our Indipix camera, we're aiming for towards room temperature. This camera would be used for the mid-wave infrared wavelength range and has potential application for many things. One of them is gas detection. For example, clouds of methane, clouds of butane, propane, and other hydrocarbons. There are also biomedical applications. For example, cholesterol. It would be able to distinguish the good cholesterol from the bad cholesterol, which is something that low-cost commercial devices at the moment cannot do. What we have delivered as part of the Indipix project with QuantIC is small format prototypes. So the next step is actually transferring this to a manufacturing line to package it into a prototype camera that then we can trial for field application. There's a really strong interest from companies operating in the sectors that could use mid-wave infrared technology, and they are looking for an alternative to what is currently out there. You want to see your research being used. That's really what motivates me. I enjoy a challenge, and I enjoy it even more if solving that challenge has an impact in the wider world. I started being involved with QuantIC when it was in phase 1, and I have to say the expertise that I gained with the QuantIC program helped me to develop, because I've recently become a lecturer. So besides being a technology that I really believe in, it's also a technology whose development has supported the advancement of my career. There's a culture of support within QuantIC for great research ideas and also for the researchers that are behind those ideas.